All right, welcome back. Today's lesson is basically us in the pursuit of being as lazy and efficient as possible. All right, so the name of the lesson is going to be special right triangles. Special, it's a right symbol, right triangles. Okay, now before we get into special right triangles, let's just do a little review over what we learned in 8.1. 8.1 was the Pythagorean theorem. It says, what are the requirements to be able to use the Pythagorean theorem? Do you guys remember what one really important thing was? Triangle had to be right. And then almost always you needed two of the three sides. Why do I say you need to know two of the three sides most of the times? Well, sometimes if both of these were x, then you could technically still go over and solve that using the Pythagorean theorem. Now, if you had that being x, that being y, and this being 10, there's not much you could do here, even if it's a right triangle, because you have too many things missing. All right, now, one other thing. You guys probably remember we were talking about Pythagorean triples. An example of a Pythagorean triple is 3, 4, and 5, or any multiple of that. Why is it nice to memorize that? Well, if you see a right triangle and you see that's 3 and that's 4 and you don't know what this is, rather than going through the whole process of doing the Pythagorean theorem, if you've memorized your Pythagorean triple, you'll go 3, 4, oh, I know this is 5, and you can skip the whole Pythagorean theorem. All right? Now, what does that have to do with today's lesson? Basically, what today's lesson is there are these special right triangles where you only need to know it's right and you only need to know one of the sides and you can find all the other sides. Not only that, but you don't have to do any kind of Pythagorean theorem or anything like that. You can go over and just know one side and basically work your way around the triangle to find all the rest of the sides. For example, this is considered to be a special right triangle. If that is 90 here, and this is 45, and this one is 45, just knowing one of the sides, you can figure out all the rest of the sides. Okay? But once again, that's because it is a 45, 45, 90 triangle. The other special right triangle that we're going to be looking at is a 30, 60, 90. If you have a small angle 30, 60, and 90, if you know one of the sides, let's say you knew this was 5, you can figure out all the rest without using the Pythagorean theorem or anything. It's really quick. You can run your way around. Now, with that said, a lot of people struggle with this, and it's not something that goes away. You have to know this to be able to do stuff later on in geometry and especially in Algebra 2 and pre-calculus. So don't go over and say, I'll take the C for this test, and I'm just not going to learn 8.2. You're going to need to know this going into future classes. You use it a lot. All right, so let's go ahead and take a look at this. This is the first one, a 45, 45, 90 triangle. What it is basically in a 45, 45, 90 triangle, the hypotenuse is going to be square root 2 times bigger than each one of the legs. And we know the legs are going to be the same length because of the base angles theorem, or the converse of the base angles theorem. Okay? So what that means is if you have a 45, 45, 90 triangle, and you knew this side, you just multiply by rad 2 to get that one. And if you knew the hypotenuse already and you wanted to get one of the legs, you divide by rad 2 to get that side. All right? Now you can easily use the Pythagorean theorem on this, because if this is x and that is x, and we wanted to know what the other one was, well, x squared plus x squared equals c squared, 2x squared equals c squared. And then at this point right here, what you would be able to do is, let's see, square root and square root, and you end up getting the square root of 2, and the square root of x squared just gives you x. So if that's x and that's x, then this one over here is going to be square root of 2 times x. Now, I teach this in two different ways. I teach you how to kind of just memorize what to do going from one side to the other, but a lot of people mess up on when to do what. So I also can show you how to do this if you are just using similar triangles. So let me show you how this works. right here, if we wanted to go from this side to that side, it is getting bigger. So we are going to multiply. And we are going to multiply by rad 2. Okay? So if you had a 45, 45, 90 triangle going from here to here, it just multiply by rad 2, and going from here to here is dividing by rad 2. Now inside of this is some algebra where you need to know how to simplify radicals and such. So right now, we know going from here to here, we are getting bigger and we are going to be multiplying by rad 2. So all you do is take what you already had, 2 rad 2, multiply by rad 2, see what you get. 2, and then rad 2 times rad 2 gives you rad 4, and rad 4 is 2. So you end up with the number 4. That side length is 4. All right? Now you might be asking me, well, you said that there was another way we could do it where you use similar triangles. Well, you know this is going to be 1, 1, rad 2. You could always use this. Now what you do is you set up a ratio. This one is to this one, as this one is to this one. And all you do is cross multiply. If you get cross multiply, you will get your answer. This would give you 2 rad 2 times rad 2 gives you 4. Let me show you another one. Now it's not always true that if you multiply by a number it gets bigger, because you could always be multiplying by a fraction. But in this case, I want you to, for this lesson, if something is getting bigger, you can assume that you are multiplying. If it is getting smaller, you can assume that you divide. So this, we're going from a side that's shorter to something bigger, so that would be multiplying. So what number do we multiply by? Rad 2. So we do 4 rad 2 times rad 2. And you get 4 rad 4. We already talked about rad 4 being 2. And 4 times 2 is 8. So that side must be 8 right here. You should have learned at the end of your algebra studies how to deal with radicals. Now watch this. We are getting smaller. We know the hypotenuse. Now we're trying to find out what this side is. When we're getting smaller, are we multiplying or dividing? We're dividing. What are we dividing by? Rad 2. So 9 rad 2 over rad 2 cancels, and you end up with just 9. That is 9, and this is 9 as well, because it is a isosceles triangle. All right, let's keep on rolling. Now, this is where it gets a little hairy, because you're going to have to be dealing with radicals, and you have to remember how to work with radicals. So here, we are getting smaller. Do I multiply or do I divide? Divide. What do I divide by? Rad 2. So 2 divided by rad 2. Now this is where you need to remember your algebra. I think it was from like chapter 10 in your algebra class. You're not allowed to have a radical in the denominator. So the way you can get rid of any radical is by multiplying by that same exact radical, because we have this thing that is any radical times itself just gives you whatever's under the radical. It gets rid of the radical. And the reason being is because this is going to give you rad a squared, and those things cancel. So any radical times itself gets rid of the radical. So here, if I wanted to get rid of this radical right here in the denominator, I would multiply by rad 2. Now the thing is, you're not allowed to just multiply the denominator by something. You have to multiply by the numerator as well. And that gives you 2 rad 2 over any radical times itself, just gives you the number under the radical. And the last thing I might want to do here, or I should do, because I'm simplifying it, is cancel out any numbers that are outside of the radical. So we have, or reduce them. You had a 2 and a 2, they cancel out. So this is just going to give you rad 2, and that one's going to give you rad 2 as well. All right, if you did not learn this or remember it from the end of Algebra 1, it's going to be a little bit tricky, because now you're trying to learn two things. You're trying to learn how to deal triangles and you're trying to learn how to deal with special right triangles. Here's another one. Getting bigger. Am I going to multiply or am I going to divide? Multiply. What am I going to multiply by? Rad 2. Yay. Okay. Now just a quick geometry review. Let me go ahead and I'll just white this one out and we'll skip this one. So some things that you need to know with radicals. Here is thing one. Any radical times itself just gives you the thing that's underneath the radical. Another thing is you are not allowed to ever have a radical in the denominator. Can't have a radical in the denominator, and the way that you get rid of it is you multiply by that same radical in the numerator and denominator. This will get rid of the radical in the denominator, and then you'll have a radical in the numerator. So those are two things you need to know about radicals. Another one is, I think we've done this in class, but I'm not 100% sure. If you had radical like 320, the way you simplify a radical is you divide by 2 until, like, you go through your primes, you divide by 2 till 2 doesn't work, then you go to the next prime, which is 3, then 5, and so on. Let me just show you this process. So if you had rad 320 and you wanted to simplify it, what I mean by simplify it is if you had like 7 halves as a fraction, you might want to leave it as improper, or you might want to pull out as much of the integer as possible. 7 halves is the same thing as 3 and 1/2. So this is kind of like the concept with a fraction. Now with a radical, the idea is you want to pull out as much stuff from the radical as possible. And let me show you how to do that. You divide by 2 till 2 doesn't work. 2 times 160. 160 is 2 times 80. 80 is 2 times 40. 40 is 2 times 20. This is only 2's. I didn't give you one that where you have to use other numbers. 20 is 2 times 10. 10 is 2 times 5. Oh, now it's not divisible by 2 anymore. So go to the next prime. 3. Not divisible by 3. Go to the next prime. 5. 5 times 1. 2 2's, 2 2's, 2 2's. Each double releases a single one of those numbers. 2 times 2 times 2 is 8. And then all the numbers that are left over you multiply together and that gives you the number under the radical. So this is equivalent to that. Okay. So when I tell you to simplify a radical, that's what I mean. Once again, we have time in class for me to answer questions on this as well. So just understand that if you have any questions over how do I deal with radicals, just ask me in class and we can go over it again. This is kind of 2 lessons if you didn't remember this from Algebra 1. All right, let's go back to the actual topic here. Am I getting bigger or smaller? Smaller. So am I multiplying or dividing? Dividing. What am I going to divide by? Rad 2. 4 rad 2 over rad 2. Those cancel, so you end up with just 4. Now this one is probably the hardest one of the bunch. How do we go from here to here? Are we getting bigger or smaller? Smaller. So should I multiply or divide? Divide. Divide by what number? Rad 2. So it's rad 5 over rad 2. Now this is where the whole, well, you can't give that as an answer. It's ugly. You have to actually simplify it. What is wrong with this? It's got a radical in the denominator. So to get rid of that radical, just multiply by itself. Whatever you do to the denominator, do to the numerator. You end up with rad 10 over any radical times itself gives you the number under the radical. At this point right here, one of the numbers is under the radical, one is not. So you cannot go over and just reduce that as is. What you do is see if you can simplify this. Let's do that little table. 10 is 2 times 5. 5 is 5 times 1. When you have no doubles, it means that you cannot reduce the fraction. Or you cannot simplify the radical. So right here, that's your answer. This one right here, if we were getting bigger, are we multiplying or dividing? Multiplying. Multiply by what number? Rad 2. 3 rad 6 times rad 2. 3 rad 6 times rad 2. All you do is the numbers on the outside of the radical get multiplied. So it's kind of like by default at 1. 3 times 1 is 3. Inside times inside, rad 12. The last thing you have to do is see if this thing can be simplified at all. 12 is 2 times 6. 6 is 2 times 3. Is 3 divisible by 2? Nope, so go to the next prime, which is 3. 3 times 1. The double 2 is going to release a single 2 outside. So rad 12 is technically 2 rad 3. And since there was already a 3 outside, then you end up with 6 rad 3. Okay, going through this one more time. The idea is if you have a 45, 45, 90 triangle, just knowing one side, you can use some steps to find out what all the other sides are. The rule is basically if you have one of the short sides, you just multiply by rad 2 to get the bigger side, and if they give you the big side and you want the other one, you divide by rad 2. That's all you do. I showed you a second way to do it. If you keep messing up on that and forgetting what to do, you can always just go over and draw a triangle, which is a 1 by 1 by 1, 1 rad 2 triangle, and then set up your proportion and solve. Okay, that was one of your special right triangles. Let me show you the other one, and then we are done. So here is your other one. Where are we? There we go. Okay, so the other one is a 30, 60, 90 triangle. Now, how this works, I'm not even going to write this in right here. How this works is there is a ratio of sides that you know is definitely going to be true. How it works is you'll have 30 degrees, 60 degrees, and 90. You'll have a short side, a medium side, and a long side. The ratio of the sides is going to be 1, 2, rad 3. 1, 2, rad 3. We're going to be doing the same exact thing, but now we have different numbers we're working with, because with our 45, 45, 90, we just multiply by rad 2 or divide by rad 2. Now we have different numbers. If you are given your short side and you want your hypotenuse, it's getting bigger, so you multiply, and you just multiply by the number 2. If they give you the hypotenuse and you want your short side, it's getting smaller, so divide, and divide by 2. If you're going from here to here, multiply by rad 3. If you're going from here to here, divide by rad 3. We never go from the long side to the medium or the medium to the long. We always would go over and stop off. Even if they don't ask us for it, we would stop off in the land of the short side. You can also just set this up as similar figures, similar triangles. It'll always work, it just takes slightly longer. So let me go ahead and show you how this works. Let's start with this one because it's easier. I want to remind you, here is the ratio. 1, 2, rad 3. Multiply by rad 3, divide by rad 3. Multiply by 2, divide by 2. So on here, how do I go from here to here? It's getting bigger. Multiply. What number do I multiply to go from the short to the hypotenuse? Multiply by 2. That gives me 10. Going from here to here, I'm getting bigger, so I'm going to multiply. What number am I going to multiply by? How do I go from here up to there? Multiply by rad 3. 5 rad 3. Done. Now let me show you how you would do this if you were doing similar right triangles. So let's just set this up. 1, 2, rad 3. Let's say we were solving for that. Okay, so all you have to do, that's a 3. 5 is to 1 as x is to, and then you'd cross multiply, you'd get x equals 10. Then you do it again for this side if you were solving for that. 5 corresponds to the 1 side, just like y corresponds to the rad 3 side. 1y equals 5 rad 3. Okay? So go ahead and do that if it helps you. I kind of just jump around the figure though. Okay? Let me show you what I mean by that. I'm going to jump around to different problems based off of how difficult they are. This first problem is actually really hard. So let's take a look at this one now. This one's actually pretty easy. I'm getting smaller. Remember, here is our figure. 1, 2, rad 3. Getting smaller, so I'm going to divide. And what am I going to divide by? Divide by 2. That gets me 5 here. Getting bigger, so I multiply. And what do I multiply by? Rad 3. So you get 5 rad 3. And that's how you jump around the figure. Let's try another one. How do I get from here to here? It's getting smaller. Divide. What do I divide by? Remember, going here to here, you multiply by 2. Here to here, divide by 2. Divide by 2. So this would be rad 5 divided by 2. How do I get from here to here? Getting bigger. Multiply. Multiply by what? Rad 3. Rad 5 over 2 times rad 3. That gives me rad 15 over 2. There you go. Only going to do a few more and then we can work through some in class. How do I get from here to here? Well, we already looked at this. 1, 2, rad 3. Talked about how you multiply by 2. So this times 2, 2 rad 3 times 2 is 4 rad 3. Going from here to here is also getting bigger, so it's multiplying. 2 rad 3, but we're going to multiply by rad 3. Any radical times itself gives you the number under the radical. It's a 6. So we found out what the exact value of those sides are by just knowing one side and knowing that it's a 30, 60, 90. Okay. Now this is going to be a hard one. 1, 2, rad 3. Multiply by 2, divide by 2. Multiply by rad 3, divide by rad 3. How do I get from here to here? That would be divide by rad 3. Now we have to simplify that. Remember, to get rid of a radical, you just multiply by itself. It's going to give me 3 rad 3 over any radical times itself gives you the number under the radical. And we can cancel out those because they're both outside the radical. How do we get from here to here? Getting bigger, so multiply. Multiply by what number? 2. 2 rad 3. There we go. Okay, I want you to tell me what this is going to be right here. If this is 7, what's x going to be? It's getting bigger, so you're going to multiply. What number are you going to multiply by? You're going to multiply by the number 2, and you end up with 7 times 2, which is 14. Now what's this one going to be? It's getting bigger, so you're going to multiply. What number are you going to multiply by? Rad 3. 7 rad 3. All right. All right, let's do one last one. Wrap it up. How do I get from here to here? Am I getting bigger or smaller? Smaller. So I'm going to divide. What number am I going to divide by? Divide by 2. 10 rad 2 over 2. can only simplify things that are both under the radical or both not under the radical. So those are both under the not under the radical, so I can simplify those. 10 divided by 2 is 5, so it's 5 rad 2. How do I get from here to here? It's getting bigger, so multiply. What number am I going to multiply by? Rad 3. 5 rad 2 times rad 3. Outside times outside. 5 times by default a 1 here. It gives me 5. Inside times inside is rad 6. All right, let's wrap this up. I want to remind you, Pythagorean theorem, you need two sides and it needs to be a right triangle. That's how you use the Pythagorean theorem. Pythagorean theorem. What we're dealing with now are special right triangles. The two that we looked at were a 45-45-90 triangle and a 30-60-90. 30-60-90 triangle. The ratio of the sides of a 45-45-90 are 1, 1, rad 2. And the ratio of the sides for the 30-60-90 is 1, 2, rad 3. If you're freaking out thinking 3 is bigger than 2, that should be the longest side, it's rad 3. Now, once again, if you are missing a side, let's say you wanted to know that, and this was 5, one way you can do it and always get it right is just set up similar figures and set up a proportion. 5 is to rad 2 as x is to 1. You would get rad 2x equals 5, and then you would just solve this. Or you can do what we talked about, multiply by rad 2, divide by rad 2. You can do the same thing with this one. Let's say you knew that this was 5 and you wanted to know what that was. You could go over and say, well, the 5 corresponds to the rad 3. 5 corresponds to rad 3. And x corresponds to the thing I'm solving for, which is 1, and you can cross multiply. Or you can do the just remembering, multiply by 2, divide by 2. Multiply by rad 3, divide by rad 3. And we never go from the medium to the long or the long to the medium. We never do that one. All right, come to class with questions.